Hi, I'm Akihiro Suda from NTT Corporation in Japan. In this session, I'll talk about reproducible builds of Docker images. This is a technique to reproduce bit-for-bit identical image binaries from Docker files using BuildKit. This is quite useful to reduce concerns around software supply chain security in Docker files. Here is the background. So security assessment has been very hard for Docker images due to lack of verifiability in the software supply chain. So when you want to verify an image on Docker Hub, maybe you can get Docker file from the source code repo, and you can review the Docker file to see if it's harmful or not. But still, you can't prove that the image was actually built from that Docker file. Potentially, an image might have been built from another source that contains malicious code. You could still check image signatures, such as cosign or notation, or maybe open pub key, but you still have to trust the signers, and you still can't prove that the source code can produce that image. Reproducible builds help proving it. So you can reduce concerns around that image, but whether the code is harmful or not is another topic. So you still have to review the code. So what's actually reproducible builds? It means that when you have the same source code, you can produce the same binary. This reproducibility has to be attestable by anybody who has access to the source code. And it has to be attestable at any time. So when you build an image today, the image must be identical next week, and next month, and next year. So it has to be attestable at any time. So why do we need it? It's because non-reproducible builds cannot be proved to be buildable from harmless source code. Let's see an example. You pull some image from the registry and get some SHA-256 digest value, such as SHA-256 AAAAA. Let's call that this is an upstream build. And then you find the source code repo of the image, and inside the source code repo, you find the Docker file like this, and the Docker file has some command to install gcc and make, and run make to build application binary inside the image. And so now you have the Docker file, you can build the image by yourself. But if the image is not reproducible, you get a different SHA-256 digest value. So in this example, the upstream build has SHA-256 AAAA, but after you build the Docker file by yourself, you get a different digest SHA-256 BBBBB. So in this case, the image is not reproducible. So you can't be sure whether the upstream image AAAA was really built from the source code repo. Potentially, it was built from another source code that contains malicious code. But if the image is reproducible, you can prove that the upstream image is actually buildable from the source. So you can trust this image, and in general, you can also say that the publisher of the image is more trustworthy than other image publishers. But reproducibility itself doesn't prove any harmlessness. And non-reproducibility doesn't prove any harmfulness either. So reproducibility just proves that the image is actually buildable from its source code, and the source code still has to be reviewed. The source code may still be malicious, but at least we can say that the image contains no secret code that you can actually never review. So you have everything that you want to review. And let's take a look at whether Docker Hub images are actually reproducible or not. And the answer is no. So most of the images on Docker Hub are not reproducible. So as an example, let's take a look at the Golang image. So Golang 1.2, 1.1 Alpine, you can pull that image. And after that, you can use Docker build command to build the same image from github.com/docker-library/golang.git. But in this Docker build command, you have to set Docker BuildKit to 0, and you have to use Docker 20.10.23 because this configuration corresponds to the current Docker Hub image. But this only applies to the current version of the image. So in the future, this configuration will change. So in the future, you have to set BuildKit to 1, and you have to use a newer version of Docker. But this configuration is the current Golang images configuration. And you can use go install and github.com/reproducible container/diff OCI. So diff OCI is my tool to compare OCI images. OCI here means Open Container Initiative, as you know. And so you can use diff OCI command to compare the upstream Golang 1.1.1 alpha image with your own build. Let's do that. Yeah, so we can use diff OCI to compare the image and use this to see the results. This takes a couple of seconds. And now we have result. And this image is not reproducible. So you have a bunch of diff. So the font might be very small, so you can't read that, but it doesn't matter because the output has more than 14,000 lines. So because timestamps are different, and the ordering files in the image archive is also different. So you get these differences. Yeah. There's very many differences, but you can't read this obviously. Yeah, so we have more than 40,000 lines of diffs, so the image is not reproducible. But we have a dash semantic flag to ignore boarding differences, such as timestamps and ordering of the file in the image archive. And then you get a much shorter result. So let's try again. Dash semantic So the diff command now ignores timestamp differences and other boring differences. So now you only get about 12 lines. Yeah, so we can actually take a look at these differences. Yeah, so one of the differences is WHWH OPK file. This is called AUFS whiteout, and this file differs due to file system difference across Docker Hub's machines and my own laptop machine. So this file system is slightly different. And we can also note that lib/apk/db/script in the image is different because of the timestamp information inside lib/apk/db/scripts.tar. So I say that dash semantic flag ignores timestamp information, but this dash semantic flag is not still clever enough to ignore this boring differences because scripts.tar is inside the image, so the current version of default CI can't ignore these differences, but the actual difference is really boring. So even though this image is not fully reproducible, but we can explain why this image is not reproducible. So we can say that this image appears to be actually buildable from the public Docker file. So in other words, we can trust the Golang image on Docker Hub. So let's take a look at why we can't just make most of images reproducible. So there are various reasons. The most obvious one is timestamps, as I shown in the demo. The files inside the images have timestamps. And the image itself has timestamps that are shown in Docker image ls command, and Docker image inspect command, and Docker image history command. And the version of the base image differs. The base image means the image you specify with the from instruction in Docker files, just like Debian, Ubuntu, or Golang, or Python. And you run package managers such as apt-get or pip inside the image, and you also get inconsistent images across multiple builds. There is also a bunch of other reasons that makes builds non-reproducible, like file system characteristics and randomized mktemp command during build processes. So let's take a closer look at the timestamps. We have timestamps in OCI, metadata, and image layers, such as the created property in the OCI image config that is shown in Docker image ls command, and the history property that is shown in Docker image history command. We also have org.opencontainers.image.created annotation in the image index. And we have the timestamps of the files in the image layers, of course. And so we have to reproduce both OCI metadata and image layers. But let's take a look at the metadata first. BuildKit supports writing the timestamps of these OCI metadata since BuildKit version 0.11. You can use buildctl command or Docker buildx command like this with the source date epoch argument, like build ctl build dash dash opt build arg source date epoch equal the command result of git log dash one dash pretty %ct. So this is a Unix epoch number. So it's integer number that presents sequence from 1970 January 1st in the UTC. So in this example, git log command is used to set the source date epoch value to the timestamp of the current git commit. But the support for source date epoch was incomplete in BuildKit version 0.11 and 0.12. So I suggest to use BuildKit version 0.13. So this is still beta at the moment, but this version is highly recommended for reproducible builds. Because version 0.13 supports rewriting the timestamps of the files in the image layers. So with these commands, you can set rewrite timestamp true to rewrite timestamps in the image layers. So this is slightly complicated, but you can see that the build arg source date epoch is just same as the previous one. And in the dash dash output argument, you specify type to image and a name to the registry, such as example.com/image, and set push to true or false, and set rewrite timestamp option to true. So as I said, version 0.13 is still not released, and the CLI may still change, but you can already try this in the master branch. So let's try that. Yeah, so as a demo, we have this Docker file, and in the Docker file, we run touch command to create a file with the current timestamp. And we can build this with this Docker build x command or build ctl command with BuildKit version 0.13 and build some image. And now we have OCI tar. And we built OCI tar twice, and let's compare the results. So we make a backup OCI tar. And the bronze cache. And build the image again. Yeah, so let's compare OCI.tar and OCI back. Yeah, so now we have a completely identical image archive with BuildKit version 0.13 and with a rewrite timestamp true option. And the source date epoch argument is also propagated to containers as an environment variable, and it can be consumed by GCC, cron, CMake, and a bunch of other tools to make application binaries reproducible. You can see reproducible builds.org to see the details about GCC, cron, CMake, and a bunch of other tools. And the next topic is how to pin the base image, like from Debian. So when you have from Debian, this may result in a random version of Debian. So you may specify a version like Debian colon bookworm, but this is still not enough. So you can specify the timestamp like this, Debian colon bookworm dash 20230904 to get the snapshot from September 4th. But this is still not enough because potentially this image can be still modified if the upstream image on Docker Hub was compromised. So it's recommended to specify SHA-256 digest like this. And it should be emphasized that you can run up-to-date on this bookworm September 4th image, but this still installs the latest packages, not the snapshot from September 4th. So this is still not enough to this is still not enough for reproducible builds. So we have to pin the package versions. And this is not difficult for Debian and Ubuntu because snapshot.debian.org and snapshot.ubuntu.com keep all the packages. So you can create a etc apt/sources list file like this. So in this etc apt/sources list file, you have snapshot.debian.org/archive/debian/20230904 to install the deprecated packages from the snapshot on September 4th. But as you know, this is really complicated. So to simplify this, I made a shell script, repro sources list.sh. This script configures /etc/apt/sources list file and also enables caching DPKG files using run-mount type cache target /+/cache/apt. This caching is practically necessary for reproducible builds because snapshot servers like snapshot.debian.org and snapshot.ubuntu.com are very slow compared to regular Debian servers and Ubuntu servers. So the script configures up-to-date to preserve the downloaded DPKG files or /+/cache/apt. And BuildKit has /mount type cache option to process the cache across multiple builds on the same node. And you can also save the cache on GitHub Actions using BuildKit cache dance action like this. So in the GitHub Actions YAML, you specify action/cache at v3 to create a cache named /cache-apt. And in the next section, you specify reproducible containers/BuildKit cache dance to preserve the /cache-apt into GitHub Actions cache infrastructure. And here is some discussion about the signature of the packages. So when you have cache, you have to be careful about the origin of the cached contents. The packages on snapshot.debian.org are signed by Debian, just like the regular up-to-date repositories. But it's important to run up-to-date update command every time because up-to-date update verifies the signatures against the package metadata or fetching these package metadata. And if these metadata are compromised, apt-get update will fail. And if the cache dpkg files are compromised, apt-get install command will fail. And the situation is the same for Ubuntu too. And basically, you can trust the signatures of Debian, but you may still argue that you don't trust them. In that case, you can reproduce the most of the Debian packages by yourself, and you can refer to wiki.debian.org/reproducibility/how-to to reproduce the Debian packages by yourself. And they say that 95.3% of Debian bookworm packages are reproducible. And you should also consider using NixOS instead of Debian and Ubuntu, because reproducible builds is much easier with NixOS. But NixOS itself is often considered to be hard to run. But in the case of NixOS, you have a log file called flake.log that contains a checksum of the sources. This is similar to go.sum file in the case of Golang. And if the binary is present on cache.nixos.org, the cache binary is used. Otherwise, the package is built from the source code with very good reproducibility. And they say that more than 99% of Nix packages are reproducible. And yeah, you can also use BuildKit to build Nix images. Like we have flake.nix, and in the first line, we have the BuildKit syntax to specify the front-end image. And this Nix file has command to initialize the image for NGX server and install packages like bash and GNU grep, NGX, and create index.html file. And in the directory, there is a flake.log file. And this file contains the SHA-256 digest of the source code on GitHub. And I don't have time to try building the image, but you can just use Docker build, and you can specify flake.nix as a Docker file like this. So this takes some time, so I just stop building the image here, but you can see that you can use BuildKit to build Nix images like this. And the last topic is about Alpine Linux, Rocky Linux, and Alma Linux. So reproducible builds is really hard with these distributions currently, because these distributions do not provide snapshot servers like snapshot.debian.org. So you have to preserve /etc/apk/cache or /cache/dnf, etc. by yourself. And you can find example Docker files in my Git repo. And in the long term, BuildKit front ends may have features to help pinning packages, maybe with SA provenance. Yeah, so for the case of Alpine, Docker file looks like this. So this is very complicated. Yeah, but there is an argument called PKG cache, and this PKG cache argument defaults to the PKG cache local stage in this Docker file, and this PKG cache local stage collects APK packages into /etc/apk/cache. So this is used by default, but you can push this to a remote registry, and you can change PKG cache argument to a remote cache by yourself. And when the cache is populated, the APK add command can install packages without network. And the package signatures are still verified by the APK command itself. So you can do reproducible builds like this, but you can see that this is very complicated with the current ecosystem of Alpine Linux and BuildKit. Yeah, so we are discussing another solution in mobi/buildkit/issues/4259. And here's some discussion about future work. So I'm planning to submit proposals to make well-known images reproducible. This is still challenging for Alpine-based images, but this should be possible at least for Debian-based images. And we also need some sort of single-click platform for attesting reproducibility and shares results with other users of the image. And here is the recap of my talk. So, sorry. Reproducible builds prove that our image is actually buildable from its source code. But whether the source code is harmless or not is another topic. So you have to review the source code by yourself. And ideally, every image should be bit for bit reproducible. But this is still challenging. So practically you can ignore subtle differences, such as timestamps, when these differences are explainable. And I have tools and examples on github.com/reproducible containers. So diffOCI is a diff tool for OCI images to analyze non-reproducible builds. And repro-sources-list.sh is a helper script to reproduce Debian and Ubuntu-based images. And repro-pkg-cache helps reproducing Alpine-based images and Alma Linux and Rocky Linux and other distributions. And BuildKit cache dance is a tool to preserve up-to-date cache or GitHub actions. And you should also refer to the document of BuildKit, build-repro.md, to learn how BuildKit supports reproducible builds. And my slides is uploaded on my GitHub profile, github.com/akihiro Suda. That's all of my talk. Thank you. Do you have questions? Hey. Anyone has a microphone?
I was just wondering, you mentioned the platform and go back like one slide or something.
Sorry, could you speak loudly?
You mentioned, what's the single click platform? Can you talk to me more about that?
So ideally, I think Docker Hub or other image registries should have a button to help testing reproducibility on their own machine. Yeah, this is mostly about the user experience. Yeah. Any other question? No? Thank you.